Yeah, good morning. So in the last class, we have discussed about the equivalent annual work method, and each cash flow we have made it as analyzed. And today we'll discuss one more way of doing this. Say for example, if I have a cash flows, if I have a cash flow, say for example P and say C1 and C2 and C3 and so on, say Cn, and also I have a salvage value. So if this is the cash flows diagram, if you have this kind of cash flow diagram, if you have, then what I am doing is I am finding the present worth of all the cash flows. So what is it is equivalent to converting this the present worth of the all the cash flows 0, 1, 2 and equivalent to say n. Means these all cash flows are converted into a single one cash flow, that is the present worth, which we knew that how to calculate the present worth at time is equal to 0. So that's what we have done in the present worth method of comparison. So for all the cash flows, after finding this present worth, this will be annualized. This will be analyzed, means the present worth will be analyzed. That is, we need to find out the what you call annuity, equivalent annuity, which is equal to, I can write the present worth, and we are finding the A by P, comma I, comma N. So after converting all these cash flows by present worth then this is equivalent to this. This is equivalent to this one single present worth. Now this is analyzed for throughout the n years. This is analyzed for throughout the n years. So we know that how to calculate the present worth of this. Say present worth is equal to, because all it is a cost dominated, we can be taking as P and plus C1 into 1 by 1 plus I, like this, C2 into 1 by 1 plus I whole square, and so on, will be getting plus S into 1 by 1 plus I whole to the power of n. So using this equation, or I can use the factors also, So C1 P plus C1 into P by the cash flow which is given, the cash flow which is given for present worth, we are going to calculate P by F comma I comma N and so on, plus F into P by F comma I comma N. So likewise, this is for present worth calculation. So first present worth is calculated, and then we'll go for calculating the annuity by analyzing this total cash flow diagram, because once you calculate the present worth, that is at time the t is equal to 0, this whole thing is represents the present worth, and this single present worth cash flow is analyzed so that A is equal to PW, I mean present worth into A by P comma I comma N. So this is how we can use the one method, and also the same can be used one more by another method called, say, future worth. Means I have the cash flows like this. I have the cash flows at time 0 and 1. We have a, say for example C1. For the same, I'm doing C2 at the end of second year, and then C3, then and so on. You will be having Cn, and this is salvage value. So this is, I'm going to convert this into a equivalent future worth. Means I'm finding the what is the future worth of this. I'm finding the future worth of this. So it is equivalent for all the cash flows which you have here, all the cash flows which you have here. So these are all converted. These are all converted into a future worth. These are all converted into a future worth. So after finding the future worth, that is same equation, we find the future worth is equal to, because this is a cost dominated, so I'll be taking P into 1 plus I whole to the power of n plus C1 into 1 plus I whole to the power of n minus 1, and so on, minus S, of course, plus Cn into 1 plus I mean C plus Cn, because Cn is also 1 plus I whole to the power of n minus n to the power of 0, so it will become n1 only. So minus S plus Cn is the future worth calculation. So after converting all these cash flows, okay, after converting all these cash flows, So we have converting all these cash flows into a future worth, So once we got the future worth, then I have to find out, analyze this. You need to analyze this by using the equation NT is equal to FW, future worth, but we are going to use the factor is A by F comma I comma N. Whereas in the case of present worth, if you use the A by P comma I comma N. And if you use the future worth for the same calculations, I can use the A by F comma I comma N. So which method you are going to use, based on that we can calculate the equivalent annual worth by using these two methods. So we'll go with one example on this cash flow, equivalent annual worth method comparison. So here I'll give and company is going to investment on two alternatives. So investment on the two alternatives, that is alternative one, then say alternative two. So here is invested, the company has invested, say for example, it is 1,50,000. So 1,50,000 investment, and on the investment on the alternative two, say for example 1,75,000 rupees, 1,75,000. And this annual return, see here annual return is there. So return in the sense it is a savings, or you can say it is a income. So it will be rupees 60,000 for this alternative, and for this alternative it is rupees 70,000. And salvage value for this investment, we have alternative one, we have rupees 15,000, and it has rupees 35,000. So this is the data which is given, and of course I'm taking the I is equal to 25%. The rate of interest is given as 25%, and life of both alternatives estimated is 5. Life is going to be estimated is 5 years. So now, if you look at these alternatives, which is the investment, the company wants to invest on these two alternatives, which is going to be the best alternative by using the equivalent annual method. By using the equivalent annual worth method, we need to find out which is the best alternative. So from this, I'll go with first alternative one. So given data, which is given as, and investment is called as first cost, right? Investment is given as first cost, that is equal to P is equal to rupees 1,50,000. You are investing this amount, means it is a first cost. Annual return is given, so which is, I will be taking as R is equal to rupees 60,000. It is a revenue, and then salvage value, which is given as S, and it is taken as rupees 15,000. And I is rate of interest. I is equal to rate of interest. I is equal to 25%. Service life is given as N, which is equal to 5 years. Now, based on this data, what we can do is we can draw the cash flow diagram. Okay. So initial cost, that is rupees 1,50,000. Then at the end of first year, there is a annual return, which is rupees 60,000. And at the end of second year also you have second year, third year, then fourth year, and then fifth year. Okay. So now this annual return is for every year we have. For every year we have rupees 60,000. And at the end of third year, at the end of fourth year, at the end of fifth year. So it is rupees 60,000, rupees 60,000, and rupees 60,000. Now salvage value is given, so I'll just add up to this, which is rupees 15,000. So 15,000 is the salvage value. Now the rate of interest is given as I is equal to 25%. So based on the cash flow diagram, then we will write the equation as we use the, say for example, I use this in this case present worth method of comparison. So I'll take the present worth first. Okay, I'll calculate the present worth first, then we'll go on annual equivalent worth. Annual equivalent worth. So here if you look at present worth of this is given as, because it is a revenue dominated, so I can take it as minus 1,50,000, 1,50,000 plus, because all are revenues, present worth of revenues we are going to calculate. Of course, I'll use the formula here. I'll use the formula here. Yeah. So we use the formula here. Minus P plus A is given. We are calculating the P by A, comma I, comma N, and salvage value is also there. Salvage, for the salvage value, you are calculating the P by F, comma I, comma N. So this is the present worth equation. So I can use this minus P is nothing but minus of 1,50,000. Then P by A, if you use the formula from this interest tables of for 25%, for 25%, I have the equation, table 25%. Yeah, 25%, N is equal to 5 years, right? So plus A is 60,000 into P by A. So P by A is going to be for 5 years. It is 2.6893, 2.6893 plus salvage value is 15,000 into P by F, comma I, comma N. So that is 0.3277, 0.3277. So simplify this and tell me how much it is present worth. So rupees, then we can use the equated annual worth. Whatever the present worth you got, P into I can, that is present worth, and I can write A by P, comma I, comma N. So use the present worth here and find out the A by P, comma I is 25%, N is for 5 years. So the present worth, the factor which I can use, this is the present worth into factor A by P, comma I, comma N, which is I'm going to get for 5 years, it is 0.3718. It is 0.3718. Okay. So then I'll get the EAW, which is equal to roughly you are going to get 6,000 rupees, 6,000 of 57. Okay, rupees 6,057 for this cash, I mean alternative. Similarly, we can go for alternative 2. We can go for alternative 2. In the alternative 2, so given data, first cost is equal to P is equal to rupees 1,75,000, and annual return rupees, that is A, it will be taken as rupees 70,000, and salvage value is given as yes, which is equal to rupees 15,000, Right. Now, based on this, of course, I is equal to 25% and N is equal to 5 years as it is. Then we'll go for drawing the cash flow diagram. So this is the initial cost, 1,75,000. Then we have the annuity 0, 1, 2, 3, 4, then 5. At the end of every year, we have the revenue of 70,000. Rupees 70,000. Rupees 70,000. 70,000. Then rupees 70,000. So I is equal to 25 as it is. Then we calculate the present worth of this by using the equation. So present worth of course salvage value is given as 15,000. So I'll be adding the salvage value at this end of 5th year. At the end of 5th year, this is rupees 15,000 is the salvage value. Now I'm writing the equation. The present worth for the given cash flow diagram is minus P. This is also revenue dominated. So minus P plus A into P by A comma I comma N, then plus S into P by F comma I comma N. So by using this, I'll be calculating the values of minus 7,75,000 plus annuity is given as 70,000. Then this P by A, comma I is of course 25. N is, this is for 5 years. Then plus S is given as 15,000 and P by F comma 25 comma 5. So by using this, I'll be getting the factors P by A 25 comma 5. P by A 25 comma 5 for 5 years, it is 2.6893. That is here, whatever we use here. Then I'll be getting the values of 1,75,000 plus 70,000 into 2.6893, then plus 15,000 into, this is going to be 0.3277. So simplify this and find out what is the present worth of this amount. So this is the present worth which you are going to get from the equation. That is present worth of the alternative 1, sorry, 2 here. Now EAW of 1. Then here we need to find out the EAW of 2. So we'll be getting EAW of 2 is equal to whatever the present worth which you got here, that is taken as P into, we are calculating the annuity A by P comma I comma Yeah, so this single equation can be used, and then we can calculate, that is EAW is equal to present worth into A by P comma 25 comma 5, so which is into 0.3718, and substitute in that equation. So EAW2, which I'm going to get EAW2 as rupees 9198, and EAW1 is rupees 6,057, because it is, as we've seen, this is a revenue dominated cash flow diagram, the dominated cash flow diagram. So we look at the which gives the more annuity, among these two will be selected. So if you look at this, the alternative one has giving only 6,000, alternative two is giving 9,180. So this will be chosen as the best alternative. So you can write the equivalent annual return of alternative 2 is higher than alternative 1. Hence alternative 2 is the best alternative to choose by the company. So this is what the statement which we have written. So this is about, we can solve the same problem by using the feature worth method also. So by writing the feature worth method equation, then we can find out the feature worth. After finding the feature worth, equated annual worth is equal to feature worth into A by F comma I comma N. There the factor will be changes. So you need to write the A by F comma I comma N. So next we'll go to the next topic, which is situations for the next topic is situations for the equated annual worth method. So one more problem, if you want, we can solve based on this, and we can go for the next topic or otherwise. So we can use this method of comparison when and all you are going to use this EAW. So that is what we can say. Situations where and all we use situations where the equivalent annual worth method is applied. So there are three situations. So one is consolidation of cash flows. When you have consolidation of cash flows, and second one is recovery of invested capital. So there I will use the annual method. Means we need to find out what is the equated annual amount which you have to be recovered. And the third one is net cash flow comparison. So here, if you look at the consolidation cash flows means when you have the consolidation of cash flows means where these different cash flows which are given in a particular company, and generally this annual may be a, for business alternatives, or it may be a decisive query in the appraisal of proposals, and it is very difficult, associated with it, the conduct or collectively analyzation. So when the cash flows are given, so conducting the, worth of this cash flows, analyzing this cash flows a little bit difficult, but still we use the equated annuity worth method when the consolidation of cash flows are given. That is, what is the worth? What's worth means this cash flows is worth or not. So when you have this question, which one is going to be worth for the to choose based on this consolidation of cash flows, then I can go for using the equated annuity worth method. And similarly, second one talks about when you are talking about the recovery of invested capital. So recovery means whether it will pay off or not. Will it? If you question the alternatives which you have, will it pay off? Means pay back to you or not? Because this investors always look at this point of right whether it is going to be pay off or not. So payoff recovers the invested capital and as well as the desired rate of return. So this covers both, that is desired rate of return as well as the invested capital. Recover the invested capital. So since the returns are spread over the life of the investment, it is convenient to convert. So it is this invested capital is spread over the total life of the investment. So that is, it is easy to convert the capital recovery cost. Capital recovery cost. So that is why we use this EAW method, where we can easily find out the how much is the annual pattern, how it is gives the annual pattern, so that we can get the payoff or not. So zero or negative, which means that the business alternatives in this could be a profitable or adequate or loss making respectively. So sometimes this cash flows which we give, the result is positive. Cash flows are maybe sometimes zero or sometimes maybe negative. So it means that positive in the sense it is always profitable, and if it gives the zero, then it is adequate, sufficient, and if it is gives negative, then it is loss making capacity. Loss making means we are going to get the loss. So once you get the net result, so if the net result is positive, you are profitable. If net result is zero, then it is adequate, and if it is net result is negative, then we can say it is loss. So based on that, we can find out. And the third one, net cash flows comparison. In the net cash flows comparison also, which one comparison talks about that, which one is the better, right? So if I want to look at which one is better, often when there are alternatives present, the criteria is, say for example, strictly is economics, and the alternative with the highest net worth is preferred. So if the worth is measured by the revenues, we are going to use the highest net worth. Suppose if the net worth is measured in terms of cost, then we use the lowest cost is going to be preferred. Lowest annuity will be preferred. So based on that net cash flow comparisons, we calculate the annuity worth. After calculating the annuity worth, which gives the more in the case of revenue dominated, that will be taken as best alternative. So which one is the best? You are going to choose based on the is a revenue or cost dominated. So these are the three situations which we can come across this use of equated annual worth method. So now some definitions before going to the next topic. Some of the definitions like service life, accounting life, and economic life. So what is meant by asset life? So asset life So for economic analysis, we can use assessment of the life of the asset is very much required. So as we taken as assessment life or service life, which is used, that is very much required for in the engineering economic analysis. So in all the equivalent annual worth method comparison, N is taken as number of compounding periods or number of interest periods or compounding periods. We can say number of interest periods or compounding periods. So which is selected appropriate for the analysis of cash flows, we will take the as the service life, right? So that N takes on special meaning when it represents the life of an asset which loses the value as a function of time. So this has the special consideration while taking the represents the life of an asset that loses the value as a function of time. Means as it is ages from 0 to n, so that loses its value. That is, life uses its value. Asset life is going to lose its value. So here, the more frequently applied to describe this life of an asset. This life of an asset is used by three different names. That is, we can say service life, which we have discussed till now, service life. And then second one, we can say accounting life. We can say accounting life. And the third one, we can say economic life. So these are the three definitions which you can say. So what is this service life? So it is the period of time an asset is kept in service by the owners, and that is why it is called as ownership life also. It's also called as ownership life. Okay, ownership life, because it is nothing but any asset which are going to kept in service by the owners. The period of time an asset, I can write here the period of time of an asset. It is nothing but the service life I am defining here. It is the period of time of an asset which is kept in service. Means which is under use. That asset is under use by the owners. That is called as service life. So we can say people accounting life is different and service life is different. Accounting life, when you define the second one, accounting life, so this accounting life is defined as life expectancy based on, this is the life which is expectancy based on primarily on bookkeeping or tax consideration. So whatever the asset which you have in any particular industry, we'll be calculating this the value of the asset at the end of every year. So for the accounting purpose, for the bookkeeping purpose, we can call it as bookkeeping purpose. So that is, we use this apply the depreciation of the depreciation concepts we can use here, so that we can how much at the end of first year, what is the life of an asset. Means this is nothing but the life expectancy is based on primarily on bookkeeping and as well as tax considerations. It may or may not correspond to the period of usefulness and economic desirability. So it may or may not be considered for usefulness as well as economic desirability. So it is only for the purpose of bookkeeping and tax consideration this life is going to be accounted. So that is why it is called as accounting life of the asset. So where we are entering into the bookkeeping. And economic life is nothing but it is the time period that minimizes the asset's total annual cost. So economic life is defined as time period. It is the time period which minimizes the assets cost, which minimizes the assets annual cost, I can say assets annual cost, okay, annual cost are maximizes the net annual incomes. So net annual income. So it is nothing but economic life of an asset. It is the time period which minimizes the asset annual cost and as well as increases the annual incomes. At the end of this economic life period, the asset would be displaced by more profitable replacement if service were still required. Say for example, the asset life which gives the more annual income and reduces the uh, cost, that we can say economic life. So after this economic life, the asset is going to be replaced. Okay, so these are the different definitions of asset life, that is service life, accounting life, and as well as economic life. So now we'll go with one more topic in this rate of return, which is called as rate of return. Rate of return. So rate of return is nothing but it is generally, which you have till now discussed, the rate of return or rate of interest is also called as rate of interest, which we discussed till now. Rate of interest also. In this rate of return, which is we have discussed till now as a rate of interest, and which is nothing but it is a percentage which we have discussed. I is equal to, say for example, 5%, 10%, 12%. That is, it is represented in the form of percentage, that relative yield on the different uses of capital. So we can say in other way, the rate of return is the rate at which the investment made gives the returns to the investors. Means suppose investors invest the amount, so he expects the return. So the return is, this return is nothing but how much rate you are going to expect the returns for the investment made by the investors. So that is what we can say rate of return or rate of interest. So there are three rate of returns appear frequently in engineering economics studies. There are three different rate of returns which appears in the engineering economics. So what is that three different rate of returns is? First one is MARR, we can call it as MARR. Second one is IRR. Then third one is ERR. Means this MARR is nothing but minimum acceptable rate of return. And this one is called as internal rate of return. And this is external rate of return. So these are the three types of rate of returns in any engineering economic studies which you can come across. So here, minimum acceptable rate of return, what does it mean? This is the rate of interest which is set by an organization. So MARR, minimum acceptable rate of return, is set by the organization to designate. Means I am expecting this much is the minimum I want to get this much rate of return. So minimum, see, the organization sets minimum rate of return which it has to get to to get a small portion of profit. Say minimum, that is said by the organization to designate the lowest level of lowest level of return that makes means the investment which that makes the investment is acceptable. That is why it is called as minimum acceptable rate of return, means which is set by the organization to designate that the lowest level of return which is expected by the organization, so that the investment is going to be acceptable by the organization. So it is trying to invest on something, and the expectation of this organization on the investment made is which is the lowest level of return which is expected. That is what we can call as MARR. So minimum acceptable rate of return, and in other words, it is defined as, say, for example, minimum acceptable return is the lowest rate of interest at which any business alternative is still attractive. So that is any investment which you have, that is the lowest or minimum rate of interest which is going to be acceptable by the business organizations. Now, this also known as the minimum attractive rate of return, not only the minimum acceptable rate of return, it is also called as minimum attractive rate of return. It's also called as minimum attractive rate of return. So this also we have, and also we have the it is the device designed to make the best possible use of limited resources in a particular organization. And this minimum acceptable rates of return is widely according to the type of organization, and also even vary with the lower than that of required for any research projects in which there is very less certainty about the cash flows, right? So research projects and all we can go for with these concepts. Next, internal rate of return. Second one is internal rate of return. So internal rate of return, the internal rate of return is nothing but the rate of interest at which it is the rate of interest at which all costs of business is equal to all its revenues. So it means that IRR at which all costs business are equal to all its revenues, that is called as internal rate of return. It is the rate of return or a rate of interest at which all the cost of business is equal to all its revenue. In other words, IRR represents the rate of interest at which all outflows equals to all inflows of the cash flows So it means for a given any CFD, or cash flow diagram, the profit, or we can say it is, when I say all are equal, means cost equal to revenue, I will not be getting any loss, I will not be getting any no loss, no gain or no profit. Okay, no loss, no profit. So it is a value at which it is the IRR is the value at which there is no loss or no profit. There is no loss or there is no profit. That we can call it as internal rate of return or return on investments. Also, it has the name. Internal rate of return is also known as return on investment, that is ROI. ROI is nothing but return on investment. And this is also called as return on investment or profitability index. It's also called as profitability index, and it is also called as time rate of return. So it has different meanings. So, but only thing is how you define this. It is the rate of interest at which all the costs of business is equal to the all its revenues. That is nothing but the rate of interest at which the cash flows having no profit, no gain, no profit, no loss is called as internal rate of return, right? So if I want to find out what is the rate of and what is the internal rate of return, then how we are going to find out? We can easily find out by using the equation. By using the equation, say net worth means all cash, net revenues. I can say net revenues minus net cost equal to zero. Equal to zero. Or present worth of revenues minus present worth of costs equal to zero, because that is what the definition at which all the costs are equal. Equal in sense the difference between this is going to be zero. So by equating this, we can find out the I. That is what we can call as internal rate of return. Internal rate of return means net cash flows is equal to zero. That is nothing but net cash flows is equal to zero. Net cash flows is nothing but cash flows of returns minus cash flows of cost is equal to zero. So by using that equation, we can find out the internal rate of return. Now, the third one is ERR. That is, we can say external rate of return. That is, we can say external rate of return. ERR, external rate of return, right? So external rate of return is defined as it is the rate of interest. It is external to a project. Rate of interest exists external to a project at which net cash flows which are generated by the project over its life is reinvested, which is reinvested. So in other words, which you can define as ERR represented as the rate of interest which is available outside the project in the real world, such that it becomes attractive to withdraw the revenues from the business and reinvest. The net cash flows of the project is reinvested in this case. So the rate of interest which are going to earn or return which are going to get that external to a project, which is represented in the form of at which the net cash flows generated by project, net cash flows which are generated by the project are reinvested, then we can say it is called as external rate of return. So in other words, ERR can be represented as it is the rate of interest which is available outside the project, in the real world, and that becomes attractive to withdraw revenues from the business and invest in somewhere else. So that is what we can say ERR. That's what we can say ERR. So with this three definitions of three different types of rate of return which we have discussed. So in the next, I think you have in the syllabus only the internal rate of return that we will discuss in the next class.